If the early universe had played by the rules we've written in our textbooks, galaxies would have been nothing more than tiny cosmic crumbs, no bigger than a few pebbles floating in space, just 500 million years after the Big Bang. But the universe, as always, had its own flair for the dramatic. It didn't follow our script, it ripped it up and said, "Watch this." Remember how Michio Kaku once warned that our neat theories might not hold up forever? Well, this is exactly the kind of moment he was talking about. Enter the James Webb Space Telescope, our shiny new window into the cosmic past. Instead of quietly confirming what we already thought we knew, Webb's shaking things up like a rebellious teenager slamming doors. All of a sudden, scientists are staring at data that says, surprise, you might need to rewrite the story of the universe. For decades, we'd believed that galaxies like our Milky Way, with its 100 billion stars, needed billions of years to take shape. Billions! That was the safe, sensible timeline. And yet, Webb has dropped a bombshell. It spotted not just one, not two, but 6 galaxies that existed only 500 million years after the Big Bang. And here's the kicker, they're up to 10 times bigger than the Milky Way. 10 times! That's like finding out a toddler is somehow stronger than a professional weightlifter. This isn't just surprising, it's downright unsettling. Something is clearly off. Either our cosmic theories are missing a huge piece of the puzzle, or the universe has been hiding secrets we weren't ready to hear. Think about it. Galaxies that massive shouldn't even exist that early. By all our calculations, the universe was still in its infant stage. But here we are, staring at giants that defy every expectation. And somewhere in the back of your mind, you can almost hear Michio Kaku whispering, "Told you so." So here's the reality check. The Webb telescope has officially thrown the biggest curveball modern astronomy has ever seen. Everything we thought we knew about the early universe is now on shaky ground. For years, astronomers reassured us that galaxy formation is a slow, patient process. It takes billions of years to build these glittering cities of stars. That made sense, right? Orderly, logical, predictable. But Webb doesn't deal in comforting stories. It deals in truth. And the truth it's revealing is blowing everyone's minds. Because let's face it, 500 million years after the birth of the universe, the last thing we expected to see was galaxies bigger than our own Milky Way. Yet, Webb saw them, 6 of them, looming like cosmic skyscrapers in a universe we thought was still learning to crawl. It's the kind of discovery that leaves you breathless, that makes you question everything you thought you knew about existence itself. Something in our grand, beautiful theory of the universe isn't lining up. It's like we've been piecing together a cosmic jigsaw puzzle for decades, only to realize a whole corner doesn't fit. And now cosmologists are staring at their textbooks thinking, maybe it's time to rip out a few chapters and start again. Fast forward 2 years since the James Webb Space Telescope's breathtaking launch, and astronomers are living in the golden age of discovery. Every new image feels like peeking behind the curtain of reality itself. But here's the catch. Along with all the stunning answers, Webb has cracked open a Pandora's box of new questions. Questions so big, they're shaking the foundation of cosmology.
And the latest twist? Oh, you're going to love this. Webb has pointed its golden mirrors toward the dawn of time, just 500 million years after the Big Bang. That's supposed to be the era of baby galaxies, faint flickers of light barely starting to assemble. But instead of cosmic infants, Webb is finding giants, galaxies that look like they've been hitting the gym since day one. Enter GZ9P3. At a redshift of 9.3, we're seeing it as it looked only 510 million years after the universe was born. And what's hiding inside? Billions, yes, billions of stars, already shining bright. Here's the plot twist. Hubble actually saw this galaxy years ago, but back then it was just a faint, mysterious smudge. Nobody suspected it was a monster in disguise. Then Webb zoomed in, sharpened the picture, and said, "Surprise!" What it revealed was astonishing. GZ9P3 isn't just big, it's weirdly mature. This galaxy didn't go through the awkward growing pains of cosmic adolescence, it skipped straight to adulthood. And when the research team zoomed in further, things got even juicier. Inside the galaxy, they spotted not one, but two bright cores. That's a giant red flag in astronomy speak, a galactic collision. Two young galaxies in the early universe literally slammed together, merging into one massive powerhouse. But the story doesn't stop there. The scientists didn't just measure the size, they peered into the very stars lighting up GZ9P3. And what they found is the stuff of goosebumps. A party of blazing hot young stars shining like a cosmic disco. But alongside them, older stars enriched with elements like silicon, carbon, and even iron. Now, here's a quick detour. Iron is the heaviest element a star can forge before exploding as a supernova. Which means for these stars to already have iron, they had to be born, live fast, die spectacularly, and enrich their galaxy all in the blink of cosmic time. In simpler words, GZ9P3 isn't just growing up fast, it's the overachiever of the universe. While the cosmos was still fumbling with its shoelaces, this galaxy had already graduated, gotten a job, and started a family. And the kicker? It has more old stars than anyone predicted. That tells us the universe was chemically maturing at breakneck speed, spreading metals and preparing the stage for new generations of stars far earlier than we thought possible. So now, scientists are scratching their heads, some with excitement, others with worry. Because if galaxies could bulk up and chemically evolve this quickly, then our carefully drawn cosmic timeline is broken. Maybe not completely wrong, but clearly missing a major piece of the story. And as if that wasn't enough to keep cosmologists up at night, there's another storm brewing, the infamous Hubble tension. You've probably heard whispers of it. The universe isn't expanding the way our models say it should be. Measurements don't agree, math isn't adding up, and the very framework we've been leaning on for decades suddenly feels shaky. Here's the deal. Scientists actually have two main ways of measuring how fast the universe is expanding, a number we call the Hubble constant. The first method looks way back, at the cosmic microwave background, the faint afterglow left behind when the universe was still a baby, just 380,000 years old. That early light gives us one number for the expansion rate. The second method, though, takes a more local approach. It uses exploding stars called supernovas, the kind of stellar fireworks so bright they can outshine an entire galaxy. Because we know how luminous they're supposed to be, we can compare that with how bright they actually appear to us. From that, we get another number for the expansion rate. Sounds straightforward, right? Only problem is, these two measurements don't agree. And not by a tiny margin either. They're way off. That gap is what cosmologists call the Hubble tension. For years, it's been one of the biggest mysteries in astrophysics, a crack in the wall of our cosmic theory. And now Webb has jumped into the game like a galactic detective, handing us new evidence that only makes the case more complicated.
Because here's the twist. Webb's observations don't just challenge the expansion rate. They reveal galaxies forming far sooner, faster, and smarter than our models ever allowed. It's as if we've been trying to finish a puzzle of the night sky, and Webb just dropped a handful of pieces from an entirely different box. Some researchers are even saying this isn't just a Hubble crisis anymore. It's starting to look like a full-blown identity crisis for the universe itself. So where does that leave us? Honestly, with a mix of awe and confusion. Equations that felt solid yesterday are being erased and rewritten today. But here's the beauty. This isn't failure, it's progress. Science grows in the gaps, in the contradictions. Every curveball the universe throws at us forces us to stretch, to rethink, to get closer to the truth. And personally, I love it. I welcome the chaos. The next time you look up at a clear night sky, assuming you're lucky enough to escape the city lights, you'll see stars. Thousands of them. And if you're really lucky, maybe you'll spot the faint smudge of the Andromeda Galaxy, our neighbor 2 million light years away. It's humbling. The universe isn't just dotted with stars, it's overflowing with galaxies, each one packed with billions of suns. Which begs the next big question. How much of the universe is actually filled with matter? And how is it spread out? Smooth and even, or lumpy and clumped together like cosmic oatmeal? Sounds like a simple question. It's not. Because once again, the answers don't line up. This latest mismatch has earned its own name, the S8 tension. So what exactly is this S8 tension? Imagine the universe as a giant 3D puzzle made of matter, some gathered into dense clusters, others stretched thin. Cosmologists want to measure exactly how clumpy that distribution is. To do it, they've got two main techniques. The first involves weak gravitational lensing, where massive objects like galaxies bend and distort the light of more distant galaxies behind them, giving us a way to map invisible structures. The second method goes back, once again, to the cosmic microwave background, the oldest light we can see. That glow carries the fingerprint of how matter was distributed in the infant universe, which we can then extrapolate forward with our standard model of cosmology. And just like with the Hubble constant, boom! Two methods, two answers. They don't match. That's the S8 tension, another cosmological migraine to go with the Hubble tension. So, what did scientists do? They turned to one of humanity's greatest tools, supercomputers. To test the theories, researchers fired up one of the most powerful computing systems on Earth and ran the largest cosmological simulation ever attempted. Because when the universe throws contradictions at you, you fight back with math, data, and a whole lot of processing power. We're talking over 50 million hours of processing time on more than 30,000 processors, all running on the UK's Drake Cosma 8 supercomputer. The project? A monster of a simulation called Flamingo. Yeah, it's a mouthful, but the mission was simple. Map out the universe in absurd detail.
Here's what makes Flamingo stand apart. Most earlier simulations only bothered with dark matter because, hey, that's what makes up the bulk of the cosmos. But Flamingo said, wait a second, what about the rest of it? So for the first time at this scale, it folded in ordinary matter, gas, stars, black holes, and all the messy, glorious physics that comes with them. Why? Because even though normal matter makes up just about 20% of the whole, it's the stuff that really shapes galaxies on smaller scales. Take galactic winds, for example. Those violent outflows blasted by supernovae or supermassive black holes can blow matter clear out of galaxies, stunting their growth. Flamingo included all of that. And as a result, it gave us the most realistic simulations of galaxies like the Milky Way and Andromeda that we've ever seen. Pretty incredible. But here's the kicker. It still didn't solve the S8 tension. Even with all the bells and whistles, Flamingo predicted galaxies should be about 7% more clumped together than what telescopes actually observe. With all the fine-tuning, that number only dropped to 5%. Still off. Still wrong. And just when you think, maybe, just maybe, we can patch things up, the James Webb Space Telescope swings in and makes things even messier. Webb didn't just confirm Hubble's earlier measurements of the expansion rate, it actually sharpened them. And in doing so, it made the Hubble tension worse. Webb looked deeper into the universe and basically said, yep, Hubble was right all along.
The universe is expanding faster than our models say it should. So now, here we are with two giant flashing red warning signs. One, the universe looks less clumpy than all our models predict. Two, it's expanding faster than the standard model allows. These aren't tiny errors we can hide under the cosmic rug. They're full-blown crises staring us in the face. And here's the really wild part. Measurement errors? Pretty much ruled out. The data has been checked, rechecked, and checked again. The numbers hold. Which leaves us with only one possibility. The problem isn't the measurements, it's the theory. That's when the conversation gets thrilling and maybe a little terrifying. What if dark matter doesn't behave the way we think it does? What if it's not there at all? What if our entire model of cosmology, the one built on Einstein's framework, the one we've trusted for a century, needs an overhaul? Some scientists are already floating radical new ideas, ideas that go beyond Einstein, ideas that could rewrite the foundations of physics itself. And maybe, just maybe, the universe has been whispering to us this whole time. You don't know me as well as you think you do. So what do you think? Is the universe pulling a trick on us, letting us build a beautiful model only to reveal it was wrong? Or are we standing on the edge of a new revolution in physics, one that will change our understanding of reality forever? Whatever the answer, one thing is clear: this story is just beginning.